but आज ही सो रही थी.
Okay, good. So here we go. Recording start कर ली है हमने. So if we say that is sound, sound means a form of energy which can be produced by using vibration of the particles of the medium. And there are so many concepts about the sound which we have to, discuss in detail. And they are that the sound waves travel, how sound waves travels, longitudinal हैं, transfers हैं, vibration of particles क्या होगी, वगैरह वगैरह वगैरह. What are the properties of the sound? Question यहाँ से आपका जो बनता है, that question is a sort of the main characteristics of sound. Mostly it is asked from you. Okay, so when we go through the sound, simply speaking, the sound is just a type of wave. It is longitudinal wave, and that has the oscillations back and forth oscillation का मतलब ये होता है कि it travels in the form of compressions and rarefactions. And when it travels through the compressions and rarefactions, it means that at some points the pressure increases. Those are called compressions, and at some points the pressure decreases. That is called rarefaction. And the distance between one compression to the next compression is called wavelength. It is very simple to understand that the distance between each compression is called one wavelength. Just see this diagram. This is the sound source, which is um, basically vibrating. If it would be a GIF file, then definitely you would see the vibration of the particles, but it is just static. So here the particles have the maximum pressure because they are closer to each other. That's why it is called compression. And this area, there the particles are getting apart, and so on. So here the pressure is less. That's why it is called rarefaction. And then again compression. So this energy is being transferred in the form of compressions and rarefaction. So the distance between the center of two consecutive compressions is called your wavelength. So this was what we have discussed. And now in this slide, I will discuss about that how we can draw the pressure time or pressure distance graph when a sound wave is being produced. For a sound wave to be produced, as I told you, that pressure will be developed or pressure will build up according to the compression position. When the particles would be compressed, the pressure would be maximum at the center of this. And when the particles would have a lot of distance between them, rarefaction, the pressure would be decreased. So there are 3 points. This is ordinary pressure. This pressure is greater than ordinary pressure, and this pressure is less than ordinary pressure here at this point. Low pressure, high pressure, and normal pressure. So that is why the compression is that area where pressure is maximum. Rarefaction is that area. This all is rarefaction. This one, that where we have the least pressure. And the distance between two compressions, actually two compressions, center of the compression is called your wavelength. But if the graph is shown in this way, so it does not mean that there is a transverse wave. It means that is a longitudinal wave. But the graph is the graph of vibration of particles, yani amplitude. So that the distance between two peaks would be equal to one wavelength. Then we would now about the audible frequency range. This is another topic what we have to discuss. That audible frequency range is a range which can be responded by the humans. So humans can respond from 20 hertz to 20,000 hertz. This is the range of sound which is called audible frequency or audible range. Above this, yani above means all the sound frequency above this is called ultrasound. And all the sound frequency below that, that is called your infrasound. We do not or we are not able to hear this, but we can detect it. There are so many animals which can, or so many, yeah, living organism which can detect the infrasound and ultrasound as well. But humans have a limitation. Allah Almighty has put limitation for hearing and listening both. For hearing, the limitation is your limitation is what? 20 hertz to 20,000 hertz. But for listening, the limitation is your, sorry, for listening, not seeing. I mean, in your vision, the limitation is 400 nanometer to 700 nanometer. Okay,
Okay.
so go back to the next slide. That is, the sound waves need a medium for the propagation through. So that is why it is a mechanical wave. Yani without medium, it cannot propagate. When it cannot propagate, definitely in vacuum there is no medium. That's why sound cannot propagate through vacuum. So when the astronauts are supposed to communicate with each other in the vacuum or in the space, what do? They use the radio wave signals for this purpose, that whether the sound can propagate from solids, liquid, gases, and vacuum. We have a vacuum tube or a jar. Vacuum, it is called a bell jar actually. There is a bell which is connected, which is hanging in between a, a jar. Inside the jar there is an electrical bell, and that bell is steel, sorry, that is sealed from the top, so no voice or no air can come out of that. There is a vacuum pump, so we can evacuate the air through this. So when we can evacuate the air through this, it means that is when the air is evacuated, before evacuating the air, just switch on the bell with the battery, connect it with the battery, then you will see that it is hammering, bell is ringing. And when the bell will ring, you can see it. It means the sound can propagate through air, yani gas, through solid, and so on. This is not from liquid experiment. Now, uh, evacuate the air through vacuum pump. Now the bell will be continuously ringing inside, but you cannot hear it. It means the sound is produced, but that cannot reach to you. Why? Because of its nature, that it cannot travel through vacuum. Yani there is a vacuum, so through vacuum it cannot propagate. So that is why sound cannot travel through vacuum. It's very simple, and the same experiment can be performed in the glass, yani in the water. So the sound can propagate through the water as well. So if you will see that the you are able to hear the sound in the water, you can simply say that sound can through propagate through the liquid. So this is that experiment. I think that much detail is enough, is it? Go to
Yes,
this
I.
part. The diagram shows a loudspeaker that is producing a continuous sound wave of frequency of 2000 hertz in air. The loudspeaker, this is a particle piece. So this particle is supposed to vibrate back and forth, right? So this particle is vibrate back and forth. That is why option A is correct. Back and forth can be back and forth, either both in this way, whatever that is, but back and forth should be its direction of motion, right? Is this clear?
Yes.
The next one is that a sound wave passes through the air. Its direction is shown, direction of travel is, and how does the particle of the air moves as the air passes in the way. So again, option B is correct. Why? Because it is back and forth. So I told you, this is a simple patronized questions which are asked from this topic. What we are discussing, which type of the wave cannot travel through air, sorry, through vacuum. So sound wave cannot. So instead of this, there is one more trick nowadays. In one option, ultrasound is written. Sorry, ultrasound, ultraviolet is written. Ultraviolet is written. So students think that this is ultrasound, so they just opt that option. So that is an incorrect approach. So ultraviolet is an electromagnetic radiation, so that it can be propagated in vacuum. Okay, is it clear?
Yes.
Move on. Yes, go through that question. the graph shows at one instant the of pressure variation along the sound wave. Pressure variation along the sound wave. Okay, so this is that question what I have discussed with you. Point P is here, point Q is here, X is given to you, and the question is which point on the diagram represents the rarefaction and what is the wavelength of the sound. So rarefaction is this point Q, and wavelength is X. Is this clear to all?
Yes.
Okay. Yeah, this is from that audible range. So what is audible range? You know that it is 20 hertz to 20,000 hertz for most of the humans, which of the following can be heard by the humans. Yeah, these type of questions can be asked to you. So should I skip them all and directly reaching to this bell jar question? The battery operated bell is surrounded by the box with the double walls. Box walls are there, then gaps are there, then bell is there, air is inside. The question is, the bell is ringing but no sound is being heard. So what is the reason? What is in the gap? A vacuum. Are you getting my point?
Yes.
The astronauts are there, and they are going to they are just two astronauts without radio. Radios can only communicate in the space if their helmets are in touch. Wow. If they just touch their helmets, then the sound will travel through the helmets, yani through vacuum. In this way, they can communicate with each other because it can pass through solid, but it cannot pass through vacuum. Okay, the same astronaut are now hammering the space. Astronaut is hammered to mend a satellite in the space. Astronaut 2 is nearby. Here, there is no atmospheric in the space. So, as compared with the sound heard by when they were working on the Earth, what does astronaut 2 hear? No sound at all, right? So, this is basically one topic, or I can say phase one. Now we will talk about the second phase, speed of sound. Speed of sound is another aspect that when we have the sound to, yani when we have to calculate the speed of the sound, there are different methods to speed of the sound. Ordinarily, the speed of the sound is usually given to you. Usually it is given to you. Mostly it is 330 to 340 meters per second. But here we will discuss about that how to determine the speed of sound, whether the speed of sound varies in different situations where in terms of pressure and something like that, so and so. So here we go, that if we say that if the speed of the sound is to be calculated, then that speed is to be measured, sorry, not measured, calculated by measuring different variables. One of them is the distance between the observer and the sound generator. The second thing, that is the distance between uh, the time. Now what will happen, you are asked about this question for 4 marks, that describe a method to determine the speed of the sound. So to determine the speed of the sound, procedure is there should be two persons, they must be apart at least 200 meters, and this is the yani open air procedure. One must be with the puff pistol, and the second should be with a stopwatch. When the puff pistol would be fired, then the sound would be generated. When this guy sees the smoke or the sound generation, this stopwatch would be started, and when the sound would be reached to this guy, the stopwatch would be stopped. So in this way, the time lapse between the generation of the sound and hearing the sound is being measured. Then the experiment is repeated and average is taken, and that is what these are the calculations. And by the method of this v is equals to d by t, because distance was measured, let's say it is 200-meter, and suppose this time is 0. Um, 3, let's say, right? If it is 0.3, what would be the answer? Can you please calculate?
200 is going to be 666.6.
Oh, it is 2. Okay, whatever the time is. Yani, you can calculate the time, you can measure the time, and this is the most important points, that the average is taken by repeating the, you're taking several readings of the time, not repeating the experiment, taking several readings of the time. You can take average, and then that would be used. So here are some problems which are here for this method. So it is really, really simple. I think I should move forward, just giving you a clue that distance would be given to you, time will be given to you, you can measure the speed, or distance will be given to you, distance, speed will be given to you, you can calculate time, whatever that is, it does not make a difference. Is it clear?
Sir,
Yes.
what role does wind play?
Yeah, the wind uh, role is actually to be eliminated by repeating the procedure in different directions. That's why I have told you that the experiment is repeated from different directions. Yeah, in different ways. Is Zainab in my class now?
Mm, s-
No?
There she is there.
Okay. So, till this point, any confusion? Now I'm going to move on. Speed of the sound in different. There is one more method, speed of the sound. Maybe it is not mentioned. I mean, I have not gone through the slides once. That's why. In the room or the lab, you can measure the speed of the sound by echo method, right? Echo method. That will be here in the slide, but uh, after this topic, echo or reflection, right? So echo or reflection method is that in which sound is being produced from one source, it is just let to reflect back, it travels a distance d to go to the wall d1, and it comes back by traveling a distance d2. So the time lapse is being measured between these two. This is the time taken. So the speed is equals to d1 plus d2 divided by time taken. Simply, what is d1 and d2? Actually, the distance is same. So you can simply say 2d divided by t. This 2d is d is the distance between wall and the source. So that is basically a room space. So in that room, if you are able to produce a sound, that will cause a reflection. Yani that can be calculated by echo method. Is it clear to all?
Yes, sir.
Okay. So moving on, the speed of the sound in different mediums is different. For example, the speed of the sound in the gases is least, lowest. Yani speed of the sound in the gas, that is equals to 330 meter per second. Speed of the sound in the liquid is almost 1500 meter per second, which is almost 5 times. And speed of the sound in the solids is almost 5000 to 6000 meters per second. Okay, so that is what, that the speed of the sound is more, but sound will be dissipated. Yani through the walls, you cannot make a louder sound to the other side, but through the walls, the speed of the sound is so rapid as compared to that of the air. So remember this thing, those materials in which the density is more, the compressions and rarefactions are produced more rapidly. This table is just a informative table, not a big deal. So the gases, liquids, and solids, so materials are there, so speed of the sound is given to you. So I told you that almost 5000 to 6000. So this is the speed It is from 5,000 to 12,000. Diamond, uh, I think diamond has the maximum speed of the sound, 12,000 meter per second, and so on. Anyhow, this is what you have to remember. Then pitch of the sound is next topic. Actually, pitch and frequency, this is the topic, the characteristics of the sound. Characteristics of sound. So the characteristics of the sounds are mainly two. One is its loudness and one is its pitch. Right? So we are talking about the pitch first. Pitch is basically the frequency of the sound. For example, if someone is having higher pitch, it means that the frequency of that sound is high. So high pitch sounds have high pitch sound has high frequency, it has high frequency, and when it has high frequency, it is called shrill sound. Okay, yeah, shrill voice. And the waves would be closer to, yani ripples would be closer to each other. For example, if you have one instrument here and that instrument is producing longer wavelength waves, so it is your low pitched sound. What is that? It is low pitch sound, and this is high pitch sound. Its frequency is high. Is this clear to all?
Yes, sir.
So the pitch of the note or the voice depends upon frequency. I told you this all. Higher frequency, higher pitch, and the sound will be shrill, right? For example, when you uh, tied the strings of the guitar, what happens? You people get, more shrill voice, more shrill strong sound, right? So uh, this is again an information that sometimes we have to measure the sound in terms of loudness. Loudness is that parameter of the sound, that how much energy is being delivered by the sound. For example, sometimes I speak louder, sometimes I speak with an ordinary voice, yani less louder. So it is called loudness. So loudness of the sound is basically that property by which we can say whether the amplitude of the produced sound is less or more. Louder sound has bigger amplitude, right? Yani loudness level कहते हैं इसको. So when we have loudness level, usually humans can hear from a very quiet sound of 0.1 decibel. Decibel is its unit. It's not included in your syllabus, but you have to remember that, to 120 decibel. So in your multimedia equalizers, there is a decibel adjuster. So when you adjust that multimedia equalizer by more than 120 decibels, so it can cause pain in your ear, right? That is one other factor, is that damages the sensitivity of the cell of your air membrane or your eardrum. And younger people can usually have better hearing at the low volume, and older people do. Definitely when we get uh, older and older, what happens? The vibration of uh, that eardrum, it becomes less sensitive. That is why we usually, did you see that we have to speak louder when we are talking to our grandparents most of the time? But there are some situations in which it is very clear, yani they are very good hair sensation as compared to us. So this is another informative slide. Leave it. Then sound wave. Here is the very important concept, right? That is, loudness means amplitude. So that voice trace or sound wave which is higher in peaks, that is louder, and that whose peaks are closer, that is high pitch sound. So you have to distinguish between this high pitch and low pitch sound in your in your questions. There would be some questions ahead, and I will let you know that how you can just consider those all. Okay, so this is yes, this is echo. So echo is but reflection of the sound. When you have cliffs are, some sort of mountains around you, then you just utter a sound, and then that sound reflects back, and you can hear the sound again, right? It is called echo. In your empty rooms, usually when we are going to have shifting in our homes, what happens when the rooms are empty? We used to we I mean, I don't know about you, but I used to enjoy whistling because I can hear my echo back. So this is basically, there are two main concepts. One is reverberation, and the second one is echo. Echo is a distinct reflection. For example, when I clap, I hear the clap back. That is an echo. But if I just get the grabbled sound, usually in the rooms, empty rooms, the grabbled sound is heard. And that grabbled sound means we have multiple reflection. So in echo, this method is what? This is that method what I told you. We can find the speed of sound. Once the sound is being sent, the distance between the source and reflection, our reflector is measured, and then the distance traveled by the sound to go to reflecting wall and coming back, this distance is measured with time. I mean, time is measured, time taken is measured in this all. And then this is 2D, 2 is 2D again. I'm telling, this is the total distance traveled by the sound divided by t, then you can find the speed of the sound. Okay, is there any confusion in this one?
No.
Okay, so this all is actually your practicing stuff. I believe so that you people will be able to manage this all. If no, then tomorrow in the class, inshallah, I will try my best to handle all the problems, because that is, yeah, Thursday and Friday class is the practicing class for this wave section, and we will have a test ahead, inshallah. Then this is the sound, quality of the sound. This is what quality is not that care your sound quality is good and your sound quality is bad. We call it now timber of sound, right? What do we call it? Timber of sound. Timber is mean, for example, if you people do not see my face, but you people believe that Sarayaz is taking class, what does it mean? You know my timbre of voice. Timbre describes the characteristics of sound which allows the ear to distinguish the sound which have the same pitch and loudness. For example, if the same pitch and loudness some other person is speaking, then you would be able to distinguish, yaar, okay, aaj to sir class nahi le rahe. Here is someone else. Do you understand?
Yes.
So most of the time when we knock the door, we are asked who is there. So we do not tell our name. हम कहते हैं मैं हूं ना, खोलो दरवाजा. So what does it mean? The people who are inside, they just recognize the voice quality. Okay, ये तो अब्बा जी है. It's okay, खोल ले. Do you understand my point of view?
Yes.
Okay, so in this case, that property of the sound by which we can distinguish the two instruments. I mean, I'm an instrument of the sound. There is another instrument. How many of you have the experience of some? I'm not quite clear about that. जब हम लोग मिलके कोई चीज पढ़ते हैं, like सुबह कोई हम लोग कोई दुआ पढ़ते हैं, कोई सॉन्ग गाते हैं, वट एवर दैट इज, when two people are speaking or singing together. So are you mean, are you clear that both are providing the same loudness? If one is louder, the second one would be dominated again, that would be suppressed. That is why they have same loudness, and they have, if they have same pitch, यूजली हम लोग ऐसे बच्चे ढूंढते हैं जिनकी पिच एक जैसी हो, तो लगे हमें कि वॉइस इज सेम, है ना? बट beside all those aspects, in spite of this all matching, we can even distinguish कि ओ ये तो अरीबा थी और ये तो खदीजा थी. Yes, is it? Do you understand my point? Then, in the same way, if you have different instruments, those different instruments can have same pitch and loudness, but they can have different wave shape, or they can produce different pattern of the sound wave. For example, if this is a mic and sound is just being produced with one of the instrument which is being which provides you this type of the wave, the other sound can be produced, the other sound can be like this. For example, this is the tuning fork. It will provide you a sinusoidal wave. But for the flute, the same type of sound will be produced in a different pattern. So you can identify, oh, this is the flute. This is the same person is singing along with all these musical instruments. But you can simply say, okay, this is a person sound. So it is the same loudness, same pitch, but its timbre is different. Same goes to guitar, violin. So this is what yeah. Now we are at the practice questions. This all session, yani these all next slides are the practice slides, right? And the first question which is in front of you, that a boy hits the railing of metal and a girl is going to hear the voice. The girl will hear two bangs. One bang which is through air and one bang through this grill. That will reach first. And the second bang which is through here, that would be later on. Right? So remember one thing, how long the it takes for the sound to reach the girl through the fence. Okay. This some data is there? No. So if here is something mentioned. The boy and girl, okay, creates the sound on the fence. The girl girl listens with her ear against the fence. 1 second after the fence is struck, the girl hears a sound through air. Yes, this is the point. If the sound takes 1 second to reach from boy to girl to air, then it will take less than 1 second. The time would be taken less than 1 second. That's why option B would be correct. And there are all the questions are there, right? So I will request you all. I am requesting you all to please go through all these questions till my next class so that we can manage the practice of the theory as well. All MCQs are given. I believe so that this is lot of stuff is available to you, right? More than I think 20, 30 questions. More than 30 questions are there, and before that you have a lot of questions. So if you people will go through all of them, then it would be very easy for me to guide you in the theory. Then ultrasound is there. Ultrasound is that sound which is basically a sound, but it's uh, yes, but its frequency is greater than 20,000 hertz. It cannot be heard by humans, but there are so many things with so many animals detectors which can detect the ultrasound. Ultrasound is used in different purposes. Like the uses of ultrasound are frequently asked in your exam. That an ultrasound is used, ultrasonic cleaning, that is a procedure in which ultrasound is just incident on some objects or some materials which are very delegated, and they can be damaged by mechanical touch. That is why we just clean them ultrasonically. Then ultrasound cleaners are used to clean many different. Yeah, any question?
No, sir.
Okay. So that type of jewelry and very precious equipments, like this is the ultrasonic cleaning, right? more than 80,000 hertz or 70 kilohertz, they are being used to clean the dust. Non-destructive testing is NDT is the method of finding the defects in objects without harming them. That is again the ultrasound test which is used in industry, that whether there are some cracks or not. So these are used. Then ultrasonic waves are emitted from transducer into an object. This is the principle of ultrasound. Please recall this one. The principle of ultrasound. That is, the ultrasounds are emitted, they are sent in terms of pulses, and those pulses are reflected back from the um, from the object, and then they are received back. The time lapse between them is noted down. Distance is already mentioned, and then we use that signal to detect whether there are some sort of cracks inside or not. So this is ultrasound technology. The source, yani ultrasound is sent, it is received back. So this is called this is used to find the depth of the sea. There are so many methods or so many areas of ultrasound in which we use ultrasound in different ways. So ultrasound is sent into the body of the patient. It reflects back from the boundary. Yes, the principle is still here. It reflects, then the depth of each layer is calculated by using the time taken for the reflected wave to return. The reflected wave or the echo are usually processed to produce the picture inside the body of the screen. So this is what you can consider. Then this is basically the ultrasound of the fetus. So the sound reflects back, and this sonogram. Sorry, this is called. Yeah, there is proper name for that. Sonograph. Yes, this is the sonograph that can be obtained by the ultrasound. So this is all about your sound. I tried my best. I could not have a speed more than that, but I tried to manage this all for you. So the remaining 2 days are very important for you. In these 2 days, you people